All right, Algebra 1B students, welcome to part 1 of lesson 9.2, where we are finally going to get to graph full-on 100% quadratic functions. We're gonna graph the real deal today. No shortcuts. So we're going to start with a reminder of what we know so far about quadratic functions, okay, from our past 2 videos. So as a reminder, in an equation of the form y equals some number x squared, ax squared, plus bx plus c, where a, b, and c are just some number, the a value affects the width of the parabola, right? Remember looking at multiple parabolas and deciding which one was more narrow or less narrow, and so on and so on. Like these two is an example that we looked at where 3 is wider than 5 because that's a smaller number. So the a value, the number in front of the x squared, affects the width. The c value, as we looked at in our last video, affects the slide up or down of the graph. So the c value right here affects up or down slide on the y-axis. Okay? So we looked at the difference between y equals x squared, where it was just a regular x squared graph starting at 0, and let's say y equals x squared plus 4, where we slid up 4 units. I hope you remember that. So the logical question for us then is about this middle guy. B times x. What does that b value affect? That's what we're going to look at in this video. All right? So in the quadratic function, y equals ax squared plus bx plus c, our regular format, the value of b affects the position of the axis of symmetry and the vertex. All right, let's look at this in action. Consider these graphs. On the far left right here, we got y equals 2x squared plus 2x. So my b value here is 2. B equals 2. Here's my vertex right there. Okay? Now, when I go to 2x squared plus 4x, where my b value is now 4, my vertex moves a little bit. I drop down there. I go further left and I drop down. Okay? Notice here that my axis of symmetry, here is x is negative 1/2, here it's x is negative 1. So by changing my b value, I change my axis of symmetry. Right? And finally, when I go all the way up to b equals 6, 2x squared plus 6x equals 6. Now my vertex is all the way over here. X value is negative 3/2, or negative 1.5. So I went from negative 1/2 to negative 1 to negative 1.5. Right? So as we can see from that example, by just changing the b value, we affect where the vertex is at. Okay? So it affects the vertex. Logical question for us, is there a rule for this? Is there a pattern we can follow? Sort of like our wider and narrower parabolas? And the answer is yes. And this time it is a formula. A little formula. This is right at the top for you of page 554. If you have your textbook and want to look there. Page 554. Okay? It says the graph of y equals ax squared plus bx plus c, our regular graph, obviously a is not equal to 0, has the line x equals this little equation as the axis of symmetry. And here's the key for you guys. The x-coordinate of the vertex is this little formula right here. Negative b over 2a. Negative b over 2a. So we take our b value right here, we make it negative, we divide it by 2 a's. Just real quick, let's go back up and look, make sure that works up here. Now in all of these, my a value is always 2, right? A is 2, a is 2, a is 2. So if I make my b negative, in this far left example I've got negative 2. Because my b value is 2. And I'm going to divide that by 2 times 2. Right? 2 times 2, that's 4. Negative 2 over 4 is negative 1/2. Negative 1/2. So it works. So you can check it here, and you can check it here. But if you take the negative of the b value, and you divide it by 2 times the a value, that's the x value of your vertex. So negative b over 2a. I'll put that back up. Please write that in your notes. That's one of the things I'll be looking for tomorrow. Negative b over 2a is the x-coordinate of the vertex. Okay. Now we're going to graph a full-on quadratic equation using that vertex and the line of symmetry and our y-intercept. Okay? So let's just review that when we put x equals 0 into our y equals ax squared plus bx plus c equation, that's the easiest one to do because this goes away and that goes away and we're just left with c, so we get y equals whatever our c value was. Right? That's where our graph crosses the y-axis. So that's called the y-intercept. Easy to find the y-intercept. You just put 0 in for x and it spits it right off for you. Okay? Now we're going to use the axis of symmetry and this y-intercept to help us graph a quadratic function. And you have 3 steps that you need to write down in your notes for graphing a full-on quadratic function. Okay? 3 steps in your notes to graph a full quadratic function. We're going to look at it in the context of this example. Y equals 1x squared minus 6x plus 4. Okay? Step 1. Step 1. Find the axis of symmetry and the coordinates of the vertex. That's the important part. Find the coordinates of the vertex. Okay? We are going to use our formula from up top to help us find the coordinates of that vertex. Because remember, this formula right here tells us the x-coordinate of that vertex. So I need my b value and my a value. My b value is negative 6. My a value is a 1. So I'm going to put that into my equation. Negative b value over 2 times a value. Okay. So negative 6 on the top. Negative times negative makes it a positive 6. 2 times 1 obviously just becomes 2. So I end up with 6 over 2, which equals 3. Okay, equals 3. So let's remind ourselves what that tells us. Now, it tells us that the vertex has an x value of 3. Now we're going to plug that in here and find the y value for our vertex. Right, so we're going to go into this equation here. We're going to take 3 and put it right in there. 3 squared is 9. We're going to put it right in there. 6 times 3 is 18, and we got plus 4 at the end. Okay, so I'm just taking the x value I just found up here and putting it into my equation to get my y value. Plugging in x is 3, and it pops out y is negative 5. So my vertex of this graph, of my parabola, is at 3 in the x, negative 5 in the y. We would go there immediately and graph that point. 3 in the x, negative 5 in the y, plot your first point. Okay, so we have now found the vertex. There it is. Step 2. Find 2 other points on the graph. Doesn't really matter which 2 points, just 2 besides your vertex. The easiest point, as we mentioned before, is x equals 0. If you put x equals 0 into our equation, y comes out to be 4. Just a reminder that our equation is 1x squared minus 6x plus 4. If we put 0 in for that x, gone, plus 4, positive 4. Okay. Second easiest point, in my opinion, is x equals 1. Because if I put x equals 1 into my equation, I have 1 squared minus 6 times 1 plus 4. 1 squared is 1, minus 6 times 1 is 6, plus 4. 1 minus 6 is negative 5. Negative 5 plus 4 is negative 1, so y is negative 1. Here's my other 2 points. I put x is 0 in there, and I put x is 1 in there because those are the easiest ones. And you can find any 2 points you want, but I always suggest x is 0 and x is 1. And our last step is graph those points and reflect across. And so you'll see what I mean by reflect across if you don't know in just a second. But I'm going to start with my vertex, as I mentioned before. My vertex is at 3 in the x. 1, 2, 3. Down 5 in the y. 1, 2, 3, 4, 5. Right there. 3 in the x, negative 5 in the y. Okay? Another point that I know is 0 in the x, up 4 in the y. 1, 2, 3, 4, right up there. And I know 1, negative 1. Okay. Now, when I say reflect across to finish our graph, here's what I mean. This point at the bottom right here, that is my vertex, right? So I know that through my vertex there is a straight up and down line of symmetry right there. So if I draw that line of symmetry, I can very easily reflect across by going here, 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 and right there's another point. And up here I'll go 1, 2, 3, 1, 2, 3, there's another point. So I'm 3 away on this side, and I'm 3 away on that side. Okay? Now I have 5 points that I can connect in a smooth curve that looks like a U. So I will do that. And there you go. There is the graph of y equals x squared minus 6x plus 4. 3 steps. They should all be in your notes. Step 1, step 2, step 3, we make our graph by reflecting across after we plot those points. Okay? If you have questions about anything I just went through, please make a note to ask me in class tomorrow. Right. But that's all I have for you today. You will get plenty of practice doing this tomorrow, so I'm not going to make you do a problem right now. Okay? Just make sure those 3 steps are in your notes and you understand what each one means. That's all I got for you right now. I will see you soon. Have a great night.